with another problem of array. Now it's squares of sorted array. So basically, you are given an integer array of nums of non-descending order. Return array of squares of each number in a sorted way. So basically, you will be given an array of numbers. Initially, that would be in sorted order, but you need to return the squares of each number, and then output should be sorted. So here's the catch. So if you just like put a square of each number and return it, it won't be sorted because minus 4 into minus 4 it would be 16, and then minus 1 into minus 1 it would be 1, and it's not sorted if you see. So you need to return the sorted output of this. So a normal brute force approach is just to visit each an element, put the like do the square of it, and then at last do the sorting of array and return the output. But that won't be an efficient solution because you will traverse in order of n time, and then you will sort the output. That would be order of n log n in the best way. So eventually your running time complexity would be order of n log n. So if you want to reduce it, so this is won't be a efficient solution. We need to do it in a linear time, right? So to do in a linear time, basically we can create a different array and store that element there, like square there, and we can make use of two pointers actually to compare the result. I will show you. Like we can we can place two pointers, one at the start of the array, second at the end of array, and would be having another array that would be eventually storing our result. And whichever is the greater element, like this pointer and this pointer, which is the greater element between both, we can just put that square to the result array. So eventually that would be a linear approach, and the eventual array would be sorted. So we'll show you. So what can I do? I can just get the length of this array first. It's a weird name, A, uppercase A. Cool. Then we can create a result array that would be a same of length, of length. Then there will be index just to traverse like this result array and put the output there. We would be needed a pointer or an index, so we will call that as index. So eventually we can start it from the end. So at the end we can start filling it. So we will compare both the pointers, what is the greater, from the end we'll start putting it. So the index would be length minus 1, and then what we can do, we'll create two pointers. One is the left pointer, that would be 0, and one is the right pointer, that would again length minus 1. Cool. So while we'll run a loop while our left pointer is less than or equals to our right pointer. So what we need to see, we need to check the first and the last element which is greater, and to that we need to make them absolute, because negative and positive we can't compare. For the comparison both should be positive. So we can use the function math dot absolute. Here we can give our left one, and if it is less than or right one, then what we can do, we can put the result array, we can fill the result array. So here at the index value we can put whichever is the greater one. So here the right one is greater, so we can just put the square of the right. and then obviously if we have put it, so right would be reduced because we are shrinking, we are coming backwards, and obviously the index would be reduced. Else if it is not the case, means our left one is greater than the right one, then we'll do the opposite. We'll put result index equals to left square. What is the element is the left, uh, put the square of it, and then again the left, because it's from left we are going forward, so left would be incremented and the index would be decremented, and at last we just need to return this result array. So hope this is fine. Let's check. Cool. So first task is passed. Let's check for another. All of them. Yeah. It's showing is accepted and all the tasks is, yeah, all the tasks is passed. Cool. Thank you.